Right, okay. So if you weren't here a moment ago, plan is for this week. This week is the final topic of Pure. It's called Differential Equations, which is, well, we'll get onto that in a moment. You're going to have a live lesson from me today and Thursday, which will cover the notes, which Mr. Stratford will put on the classroom. And we'll give you a task for Friday, same sort of plan as normal. And then, by the sounds of it, I think you should have had the notification by now. We will be back in school from Monday. So, great news as far as learning is concerned. What we will be doing on Monday is past papers mostly, or at least past paper questions, revision of old topics, preparing for whatever assessment you will have in the future. So don't ask me too much about the assessment because it's not set in stone yet, but we can certainly plan some revision. That's what me and Mr. Stratford will be doing. Then we'll be going back to sort of separate classes, no longer joint teaching. Although I think that's worked quite well, to be honest. So anyway, right, differential equations. So split into two parts. It's one of the more difficult topics, but I don't necessarily see it so difficult. I don't see why it should be so late in the year. But here are the notes that Mr. Stratford has put up. So it says for the first part of the differential equations topic, we need to get used to this thing called separation of variables. Now, you would have been used to sort of separating variables by changing the subject of a formula in the past. And we're going to treat that as a similar sort of routine to what we're doing here. So if it says make y the subject of the formula, we want y on its own, or we might want, if we're rearranging an equation with all the x's on one side, all the y's on the other, that's pretty much what we're going to be doing here. So, except the difference is we're going to be doing that, but when we are dealing with dy by dx. So it says then, we do this when we're already solving an already differentiated equation. So this sentence here is what I mean by this example we're going to be starting with here. Actually, I might do a different one to start off. But if we've already have dy by dx to start with, and we go from there to find something called a general solution. Okay, so general solution. Now, Mr. Stratford's notes are, go away, emails. Mr. Stratford's notes are excellent. I'm just going to add one to it just before we start. So, apologies, I didn't have this prepared, but my textbook is closed on me here. Okay, so question is going to be, having an here, everything's unplugged. Prepared for once. It's be a fun watch back if you're watching again. So find the general solution to, we're going to start with dy by dx is equal to 3 sine 2x. Okay, so for a question like this, if it asks for the general solution to something, then we're going to start with dy by dx, something's already been differentiated. Okay, now essentially what we want to try and end up with is an equation that is y involving something with x. Basically, get back from dy by dx. Now, for a question like this here, okay, now we need to separate the variables and rearrange it. Now, you may look at that and think, if I want to get back to y, all I need to do is integrate, which is essentially what I'm going to be doing with this one, except my girlfriend finds something on Audible in the background here. Else annoying me. Right. What we're going to be doing is rearranging the sort of dy's and the dx's and the x's and the y's to get everything on its same side, and we are going to integrate. And it may seem like a long-winded method way of doing this, but it will make sense when there are more variables involved. So first thing, I'm going to move this dx to the other side. So I'm going to start by saying dy equals 3 sine 2x dx. Okay. Now, what I've done there is I've just rearranged to get the dx on the same side as the x. Now, remember, I wanted to get to dy. Excuse me. I wanted to get to y. So if I want to get this side to become y, sort of integrating that. Now, technically, that is 1 dy on the other side. Just integrate one side and get away with it. You also have to integrate the other side. So you end up with the integral of 3 sine 2x dx. Now, if you integrate 1 with respect to y, then that just comes out to be y. The integral of 1 is just the constant that you would differentiate in with respect to, in this case, y. So, for example, if you have the integral of 1 dx, that is x plus c, but we'll deal with the fact that there's going to be a c in a minute. Anyway, so that's where this y comes from. That's how I get y out of this. On the other side, we're going to integrate this side with respect to x, because that has a dx on the end, and the equation here involves the letter x. So we could take the 3 outside like that, and then integrate whatever's inside. So the integral of sine 2x, well, the integral of sine is minus cos, so that's minus cos 2x, but we also need to divide by 2, because there's a 2 there. Now, instead of writing plus c on both sides when you integrate, you only need to write it on 1, because it's just a constant number. We can collect it all together. And that's the answer. So my steps here was I started with dy by dx. I rearranged to put the dx with all the x terms on the right-hand side, and I ended up with this thing here. Now, if I wanted to get rid of the dy and go back to y, I integrate this. And remember, this is technically 1 dy, so I'm integrating 1 dy. But if you integrate one side, you also have to integrate the other. And you end up with a general solution then involving y and x. So that's a sort of basic example just before Mr. Stratford's notes. Okay, so onto the notes. Example 1 here. Now this one is a little bit different. Hopefully you can read this. Maybe if I zoom in a little bit more. I want you to find the general solution to this equation. Dy by dx is equal to e to the x over y. Now this one is different to the one that I just did because it involves terms x and y. So it's an x on the top, there's a y on the bottom. In that one that I just did a moment ago, the dy by dx was only equal to something involving the letter x. But this one here has separate variables, x and y. We need to separate those variables and gather them on the same side as each other. And the same thing goes for the dy and the dx. We want to get the dy's with the y, and we want to get the dx with the x. Now, if we rearrange that, we sort of multiply by that y up there, and we bring the dx up the top on the other side, and you end up with this here, y dy, because we're going to times by that y up there, and e to the x dx, because we're going to bring that dx there. Okay, so now what we are doing is we want to go back and get rid of the dy and the dx, so it's just a general solution involving y and x. Now, to do that, we integrate both sides. You can't just integrate one side, you have to integrate the whole thing. And you end up with this equation here. We want the integral of y dy equals the integral of e to the x dx. Now, if you integrate all of this, y becomes y squared over 2. E to the x stays the same, but we're going to include a plus c on the end because remember there is that constant. And I've done it. I've reached the general solution. Little note on the side here from Sir. Although we have a plus c on both sides after integrating, you only need one of them because the constants can be put together. So that's the general solution. It says then, careful if the question asks you to write it in a specific form. All right, so it could ask you to rearrange it so it's y equals. Well, what we would do is just once we reach this stage, we'd rearrange it and times by 2 and square root on the other side to move to make y the subject of the formula, but you're used to that by now. Okay, example 2. There's a few mistakes in the typing that's going on here. Let me just get rid of these things so we don't need that double sign there, or there, or there, or that cos. Excuse me. I think it's just the way we type it on Word causes that, sorry. So, find the general solution to this differential equation. So we start with a differential equation. We're going back to find a solution to it involving just y and x without the dy and the dx. Okay, a lot of integrating involved, which is why it sort of follows on from the topic of integration or can be included in the topic. So again, we have an equation, a differential equation involving a y term and an x term, separate variables. Now, if you rearrange it to bring the dx to this x side and the y squared underneath here, you will end up with 1 over y squared dy, or dy over y squared, but it's easier to think of it as a separate fraction like this, is equal to sine x dx. So what we want is all our y's on one side with a dy on the end, all the x's on the other side with a dx on the end. And the next step is going to be integrate everything. Yep, integrate everything, left and right. Little tip is to say, obviously, you should be used to this by now. Write 1 over y squared as y to the minus 2. So if we are integrating both sides, you end up with minus y to the minus 1, technically again plus c, but we don't need to write it on both sides. Sine becomes minus cos plus c on the end. Okay, and you could write it again in normal form, or there are series actually move things over to the other side, so there's positives and not negatives there. So that's the general solution. Okay, there's a little bit we're going to do in the next lesson, which is working out specific solutions, but I'm going to leave that for now. Okay, and example 3. There's an important point here. I may have cut it off. This bit here. So the question asks me to find the general solution to this differential equation, dy by dx is equal to x squared over e to the y, an x term and a y term, and write that in the form where y is the subject. So I'm going to follow exactly the same steps that I've been doing up to this point, but I'm going to rearrange it afterwards to make sure that it is y equals at the very end. Now, this is a particularly tough task, I would say, for this particular question. But anyway, first of all, separate the variables. We want my e to the y over to the left. I want my dx over to the right. And I end up with e to the y dy equals x squared dx from just moving that over there and this over there. Then integrate both sides, and you end up with e to the y equals 1/3 x cubed plus c. Now the question wants y as the subject. Now I deliberately not scrolled down here. Let's have a very small bit of interaction in the chat, in the comments. I don't usually do this. I tend to lecture you, but my voice is boring. Let's have some interaction. How do I get y on its own? There.
Do you take the natural log?
Absolutely, yes. Was that Archie? Well done. Absolutely. Oh, there's a little bit of a mistake here, but very, very good. Logs was, I would have accepted if anyone had just said logs. All right, we want to get a power as the subject. So what I mean by that is when y is up there, okay, then you need to take logs of both sides, okay? Because if you, and we're going to choose the natural log because it's e, if you do ln of the left-hand side and ln of the right-hand side. You can do that because you're doing the same thing to both sides. Well, little trick with this one. If you do ln of e to the power of anything, it cancels out, okay? Because, let me just rewrite that in a different way, right? ln of e to the y. It's just if I think of what that is. That is log to base e of e to the y. Okay, now that could be rewritten without logs in index form. Okay, now what this means is e to the, well, if I, maybe I should have said, excuse me, let's go to some slightly different, neater notes for that one there. if I have an equation and I want to work out what the answer is to this now, ln of e to the y, okay, then I can rewrite this in index form, because if you have ln of anything, that is log to base e of e to the y. Now this could be rewritten, what I was trying to say on the other page, but I ran out a bit of room and I maybe didn't write it in the correct way. This could be rewritten without logs, okay? This bit on its own on the other side is the power. So e to the power of x, e being that bit there, x being that bit there, is equal to this bit in the bracket, e to the y. So the answer is just this bit up here, because x is equal to y. So that's where it comes from. But as long as you remember that they just sort of cancel each other out, the ln and the e, and you are left with then y. Or you can also think of it like you can bring the power of y down in front, because you can do that with logs, and you have ln of e, which is just 1, and you have y times 1, which is this y here. On the right hand side, then you still have ln of all of this nonsense here, but you can leave it like that because the general solution just wanted y equals. Okay, so I think that might be it. Now, what Mr. Stratford has done for you today is some practice questions in here, but this is not an assignment. Okay, the answers are down the bottom here. Okay, there's 4 questions here. If you want to have a go, just to check that you understood this lesson, that's fine. The answer's there. I'm sure you can get in touch with myself or Mr. Stratford if you didn't understand and you want to see where any of that comes from. And that's all fine. So what we're going to do on Thursday is I will have a look. Well, I could just go on to the next bit of the topic, the very final new lesson of the year, I guess. But if you want to have a go at those 4 practice questions, the answers are there. Okay, and that's it from me. See you Thursday.